at a level of 750 meters, 2,500 feet below sea level. The occurrence of the cool seams at great depths below sea level, which were originally thick vegetative areas and developed on the Earth's surface above sea level. Another example is representing by the phosphate beds occurred above sea level in some areas. These beds represent remains of marine vertebrates which dwelled shallow environment. The same applied for the coral reef colonies represented in the areas above sea level. While the living forms flourish in littoral zones of the continent shelf under photic zone, its organic rich, clear water and high energy conditions. Among the recent examples for the Earth's subsidence, the presence of submerged Roman temples, forts and coast guard stations in Alexandria. It is worth mentioning here also the Earth's movements are classified into two major types, which is the epeirogenic and orogenic movements. Eperogenesis movements, it is derived from the root eperos, it means continent, which means that it is a slow movement which acts for long geologic time and affects extensively regions of the continents or seafloor. It results in gradual uplift or subsidence of the sedimentary sequence without deformation, neither by faulting or folding. The emerged strata appear almost horizontally at high altitude above sea level. As an example for this, the movement of the Grand Canyon of Colorado River in Utah, Arizona, and New Mexico in North America. Here the marine sediments remain horizontal on the both sides of the canyon, attaining an elevation of 1,580 meters above sea level, which significant that large tract of the Earth's surface was pushed upward at slow rate for a long time in the same sequence as was originally deposited. My dear students, the second movement is the orogenic movement. It is relatively rapid movement compared to the epeirogenic movement. In the meanwhile, it changes the altitude of the strata, causing tight folding and faulting, and intensive, almost various faulting, resulting in lateral displacement for several kilometers. These features commonly extend for a long distance and occupy narrow belts of the crust, giving rise to territorial mountain chains, as the Atlas Mountains chains of the North Africa, which extend in Tunisia, Algeria, and Morocco. The Alp Mountains chains of Central Europe, which occupy narrow terraces in France, Switzerland, Italy, Australia, and Hungary, and the Himalaya north of India. In North Egypt, such mountain chains are reported extending from Maghara Massif in North Sinai to Bahariya and western deserts through the areas of Shabrawit and Abu Rawash to south of Ismailia and west of Cairo, respectively. It is noticed that the magma is extruded through deep-seated faults and ridges near the surface. When it cools down, giving rise to fine crystallized igneous rocks, either interstratified or cutting across the deep and surface rocks. In some instances, the magma ascended violently, reaching the surface, forming local volcanic with lava flows. Pluralistic materials, volcanic dust and gases resulted from this eruption. The lava flows along the slope of the volcanic cone, carrying rock boulders and transporting them to low areas where they are cooled down. Now, my dear students, let's discuss two important theories, discover and answer our questions about the Earth's constituents. Let's start with the first theory here, which is the continental drift theory. The great similarity of the eastern coastline of both North and South America and the western coastline of Europe and Africa gives the idea, if they were one land piece and drifting away from one another. Similarly, the correlatable criteria of the rocks of these continents, close features of the ancient life, and distribution of climatic belts on these two sides, and also the Atlantic Ocean, inspire Alfred Wagner, 1880 to 1930, a German meteorologist and a student of the Earth, to introduce his theory in 1922, which claims that the continents of the Earth were a huge, vast landmass formed of the shale, external mantle of the crust, whose rocks are rich in silica and aluminum, hence we call it shale. Over the sima, the interior mantle of the shale, whose rocks are less rich in silica, and about 45% of iron and magnesium. The rocks of the sima build up ocean floor and occur under the continents at greater depth. This single vast landmass started to split by the close of the Mesozoic era since 220 million years ago into a number of fragments, and by the Pleistocene time they achieved their position as our modern continents. Wagner attributed this slow drift to heat convection currents, which were capable of rifting the crust, causing pronounced relief, particularly on the edges of the large continents. As North and South America, Africa and Australia, where greater mountain chains are formed due to continental drift. Late Paleozoic glaciation. In the southern hemisphere, Cretaceous outcrops shows many striking similarities among the rocks of the various continents. These are recorded in South America, Falkland Island, South Africa, India, Australia, and Antarctica. This phenomenon reflects the existence of a great southern continent called Gondwana land. The distribution of ancient glacial deposits on the various southern lands is one of the convincing lines of the evidence of continental drift. Particularly the identical feature of the glacial elastics in both South America and Africa. We have another clue for the continental drift theory, which is the ancient evaporates, deposition, and coral reef. Evaporates and sedimentary and also sediments composed of minerals that have been precipitated from the solutions, concentrated by evaporations of the solvent in an arid climate. When such sediments are met with old geologic ages, significant the existence of great arid belts in the past, and shifted gradually through time to its present position in the modern desert arid belts, which extend about 30 degrees north and south of the equator. This suggested a relative motion of the Earth's poles and landmass of the past as compared with the present-day conditions, another line of evidence. For the continental drift is the discovery of the assemblage of primitive land plants in South America, South Africa, India, and Australia, and within 300 miles of the South Poles in Antarctica. This means that there must have been continuous or near continuous land connection between now separate continents. Furthermore, some ancient formed mountain chains now terminated abruptly at the continental margin. If these continents are joined together, their geologic structures will match up between the land masses. As an example is the close similarity between the mountains of South Africa and their counterparts in Argentina to the west and Australia to the east. This adds more support to continuity of these mountains in the past moved apart through time. What are the cases against the continental drift? As you see, my dear students, we have many clues for this theory, but in contrary we have some thoughts against this theory. This theory depends on the shape of the old iron oxide magnetic field as revealed from remnant magnetic attributes. Those who oppose this theory of continental drift claim that the Gondwanaland was huge land mass extending from South America to Australia and includes both South Africa and India. By the close of the Paleozoic era, a large portion of this vast east-west land mass was invaded by ocean waters, leaving only fragments of lands to form the present continents and the subcontinents of India. They add that these continents interconnected by narrow bridges, and after sea invasion, these land passages were drowned, and the continents acquired their present geographic distribution. The study of South Ocean's floor through deep drilling projects, however, reported missing of the seal mantle, which is lightweight layers. which builds up the narrow drowned land bridges. So these bridges needs a clue like having the granitic layer or the siyar. So we don't have this clue to prove the continental drift theory. Based on the recent paleomagnetic measurements, new data were introduced supporting the drift theory. And it becomes acceptable among scientific circles in the northern hemisphere in addition to those in the southern hemisphere. Nevertheless, the question is still far from being settled, and it is in favor of drifting continents. What is the reason? What is the factor? What is the trigger for this drifting? We then faces the question, what causes the motion of the continents? It seems it's not a vertical motion or vertical movement. We need to find a lateral movement to solve this problem. Theory of plate tectonics. This is the one clue here, which is a hot solid rock. Magma rise by convection currents from great depths along fractures, causing movements of the lithosphere in opposite directions away from a mid-ocean ridge. By injection and eruption of the new magma, a system of long, thin, growing fractures large along the fracture zones in the ocean floor. The old moving lithosphere plates plunged back into the mantle beneath the neighboring plate once in the mantle. The plates are heated up, melted, and remixed, giving rise to heterogeneous mixture of irregularly superimposed rocks. Due to differences in temperature of the slowly downward plunged lithosphere, slabs and hot fluids like mantle fractures are created, and this represents the sites of many earthquake foci. If the areas of downward plunged are delineated, prediction of earthquakes and volcanic activity could be foreseen. Thus, protective measures are carried out to save human life and properties for this natural disaster. It is not necessary for the old lithosphere to plunge into the mantle. So, continuous study and plotting of the sites of the earthquakes foci, the world maps, we find 6 large tectonic plates are traced. These are Africa, Eurasia, America, Pacific, Australia, Antarctica plates, plus a number of small ones, and as mentioned before, all are moving. It should be pointed out that deep trenches originated in ocean floors or below continents, and later the continents splits away and oceanic basin is gradually formed. As an example, the Red Sea is widening and its sides move apart by a rate of 2.5 centimeters per year. The same applies true for Gondwana continents and gave rise to the Atlantic and Indian Oceans. What are the types of tectonic plates movements? We have divergent movements of the plates called constructive movement, which arise from the forces of tension, where tectonic plates moved away from each other and the case of the mid-oceanic ridge of the Atlantic Ocean, as well as in the Red Sea, where are the examples. Also, the Arab and African plates moved apart and a new ocean is formed between the two continents. This is the case in the Red Sea. Now, my dear students, the second movement here is convergent movement of the tectonic plates, called the destructive movement, arise where two plates move toward each other, where they meet and hit together. This may occur between two continents, as that would lead to the formation of this collision. Huge mountains ranges such as the Himalayas. In the other cases, the collision may occur between two oceanic plates that would lead to sliding one plate under the other one. Consists deep trenches as well as the volcanic islands. But if the collision between oceanic and continental plates occurred, the oceanic plates of course will slide below the continental one because of its heavy density and reach to the mantle, and melts completely and arise mountain ranges such as the Andes in South America. This also shows in the Mediterranean Sea. We have the third type of movement, which is sliding movement of the plates. This arises from the movement of the edge of the one plate against another one, made up cracking causing vertical sliding features, or destruction may result in volcanoes. And earthquakes also, such as the San Andreas Fault, it also shows in the Gulf of Aqaba. The reason for the movement of tectonic plates, the movement is caused by the vertical heat distribution in the mantle, which lead to the formation of convection currents in the magma that found in the upper layer of the mantle. Convection currents are of two types. Downwards currents cause formation deep depth trenches, and rising currents causes formation of the mid-oceanic ridges. From the study of earthquakes and registration centers on the world map has been identified 7 large tectonic plates. From the earthquakes and volcanoes distribution, we can distinguish 7 major plates. They are Africa, Asian plates, North America and South America plates, Pacific and Australian plates, and South Pole plate, in addition to many smaller ones. The continents may ruptured by the oceanic ridges, which arises an ocean gradually and very slowly. Earthquakes. What are the types of earthquakes include? We have volcano earthquakes. It occurs before and during volcanic eruptions. Also, we have tectonic earthquakes, which as a result of creation tectonic activities and depths ranging between 10 kilometers to 300 kilometers. Also, we have platonic earthquakes, which have their foci deep as 600 kilometers from the Earth's surface and result from the deep fractures of the subsurface rocks. What are the types of earthquake waves? These are 3 types, each of which has its own velocity and mode of oscillation. First, we have the primary waves, which is the fastest of all and the first to arrive as any observatory as a longitudinal wave. Secondary wave, which is S waves, relatively slow and arrived after the B waves at the same observatory as transverse waves. And finally, we have the surface waves, which are the slowest of all waves, which their particles they are vibrating at transverse waves of certain velocity. Write a Richter magnitude scale. It measures the total amount of energy released from an earthquake. From the focus of this earthquake, it begins with number 1, with strongest earthquakes recorded up till now is about 8.6. Richter magnitude scale is logarithmic 1. This means that the intensity increased by 10 times when the Richter scale increased by 1 unit. Now, my dear students, we come to the end of our today's program. I hope you got benefits from our today's episode. Until we meet next time, have my best wishes and goodbye.